introduction. Yeah, in this talk, I would like to talk about Endgame, the last step of our Revm project. It started a few years ago, and I think I found the solution that's going to last for a while. Before that, let's talk about history and basic evolution of the project. It started in 2021. I took a break for the work. I basically went to the seaside, relaxed a little bit, and after I came back, I did basically want to do some project that's related to infrastructure, wanted to build something that uses EVM, and I started researching what's basically on the market. And there was like three things. Open Ethereum was the client that I worked on before, and it was GPL licensed, so it was not suitable. EVM Modim was the new one. It has some, it's built by an ex-colleague. It has some experimental and exotic Rust nightly features, and it was like just interpreter. So in that sense, it was not enough for me. Sputnik VM, I was mostly interested in it, and it was older project, older EVM, but it was not that maintained. It was hard to use it, and if you want to do inspection, tracing, you need to basically build it in some different way, and that's very hard to use. So after making PR to the Sputnik to add some generics on the instruction set, basically, after 2 weeks of no response, nothing, and seeing the project not moving anywhere, I closed that PR and made my own REVM. In the month, I had some initial code that can be run. There's PR if you want to look at that. By the end of 2021, I supported the latest forks, state test for passing. It supported all pre-compiles, and the most important interface was simple. I wanted to have, for my experience for Open Ethereum, I wanted to have EVM where you set all the data and say transact. And then basically it gives you the output of that execution. The database trait was the abstraction that allows you runtime fetching of account and storage. Environment was the way how you set transaction block, configuration, everything around it. And inspector was the good abstraction, very powerful one that allows you runtime inspection of your EVM when it's run. This PR, it was optimized a few times, but this PR was most impactful. It basically 4x the performance. It was no STD from the start. The idea was to use it in JavaScript or WASM. It was MIT license, and by that year, I basically jumped to another project, and REVM became my hobby. First adopters came next year. Foundry was the biggest one, the first one. The way how I met Georgios was he tweeted if there is any EVMs out there, and I responded on the tweet, hey, fresh feedback if you're interested. And he was in the minutes in my DMs. That's Georgios. He's basically amazing in that sense. They started integrated in a few months. I think Oliver did the first integration 5 months after the start. That was like March 2022. Hardhead started integrating their Rust backend. They published DDR this year. Builder Surges was one of the big users of the library. And they were the first one, they sync from the Genesis to the tip of the mainnet. And it was very nice to hear, hey, we are syncing, everything is fine. By the end of 2022, all forks were supported, optimization was done, our REVM.js was supported but removed by the end of the year. There is no traction. A few more optimization was done, and most importantly, RET, the client, started to be made October 2022. At that point of time, I joined Paradigm to work on the client. I think I had H from my Open Ethereum times. Second year, and RET are mostly basically focused on the client implementation. We needed to make something stable, and we did it very fastly. Team was amazing. I plan to stay there just for a few months, but I'm still there. Now in Ithaca, but either way, same team. Shanghai and Cancun were added, and time moved on. This year, Red 01 was released. Big stability improvement. It was audited. It was the people like it. People wanted to use it. It is amazing. Revm on its own hit its own milestone. It got audited. It was community driven by the SIG company, and it's by Guido, basically the guy that finds a lot of EVM bugs. There's blog posts if you want to hear more. EOF got supported, and start of the year, ZK EVM became a thing. This year, I could claim, I feel that's okay to claim that the Revm became the most popular EVM library out there, and it's become the critical component of Ethereum ecosystem. There's few types of the Revm users that I can see. They're basically clients and chain. Red first, Helios is the like client, Trin. As the execution clients, there is different chains, Optimism, Scroll, Binance, Polygon. They're all interested to have Revm in their code, or basically, in this sense, Red, and in that connection, Revm. The tooling, both the Foundry, Hardhead are basically using Revm. Builder searches, they're a little bit private, but always in my DMs, are the big users of it. And ZK EVM, basically, it became the standard library that's used in that field. There is even a grant by EF Foundation that basically targets Revm formal verification with the usage of the RISC-V and ZK VMs. This all affected the future of Revm and how I look at it. So, the problems. First problem, how to do EIP testing. How to allow EIP champions to come to the code base, improve their thing, implement it, test it in the Foundry if needed, and basically do their own thing and do basically on their own time. One of the example is transient storage. I want to just move on that path. In July 24, I got issue in GitHub. Hey, can you implement that? That was one of the EIP champions that wanted this included in Revm for him to test it in the Foundry. EIP was not included in any hard fork. There is no even notion for it to be included. So that was mostly it. A few months after, EIP got CFI'd, so it potentially can be included in Shanghai, but either way, there is not like strong guarantee. Shanghai happened, EIP was not inside. Next hard fork, Cancun. July, PR was made for that EIP. August, it was merged. In March, the EIP landed on mainnet. Approximately 4 months before that, EIP should be made inside the clients for the testing, for the DEMNets, and for test nets at the end. Another example was 3074. And I want to say all the requests that champions made were reasonable. It is from their point of view. But the question that I had is like, should I have started working on EIP right away when the first request come? It's a little bit silly because I have different priorities. I cannot do everything. Should I just merge PR when it was made? The question with that is who is going to do maintenance? Who is going to remove it if the EIP was not included? Do I do it for every IP? That will be a lot of unnecessary code. And in the end, who is going to maintain all of that? Second problem with the maintenance is how to add testing, dev, experimental features. One of those, I always try to facilitate and enable big project that depend on our EVM to give it support, to give a way to make tech functionality happen. Sometimes there was like features, Rust features that basically enable those things as configuration, but sometimes if this is only the EVM project, simple EVM project. Revm SEA, R55 integration that require different execution environment would not be possible. And problem 3 is chain support. Most EVM chains have small difference, and they're not like, they don't want to move away from EVM a lot. They're most like new chain spec, hard forks, new transaction types, maybe few EIPs. But in general, they're like small difference from the mainnet EVM. Only way to do that previously, it was like to fork the project, and that brings the maintenance issue and burden of maintaining to basically repos. So, solution for all that is to make EVM framework. And I think that's the last stage of our EVM and its endgame. What do you mean by that? Let's make the code extensible. Chain can use our EVM as the library, override the functionality that they need, add new transaction that they need, and just use it as the library. That makes the core of the library same across all the chains. Implementing new EIPs that are on the mainnet would become easier, and all the chains can just reuse the code. Tooling could create their own custom way to inspect. Maybe they need more performant way. Maybe they need Revm SEA needed new execution environment. New EIP can be implemented and tested separately. And for example, this is the first look how basically, I'm now coming to the code a little bit, but yeah, the main, inspector main, optimize, inspector optimize. You will have different types for your different EVM that you need. Initial idea came a few years ago. I looked at EVM BAM, and they had like array of functions, and array of functions that was different by fork. So my first idea was, hey, can we introduce custom instruction and make it like allow users to re-implement or add their own custom instruction? That idea expanded, so it's not just on instruction, but on full logic. And that full logic function overriding was the handler from the last year. I think it was very great idea, but implementation-wise, it was like box over pointer of function that was not the greatest and more flexible way. I liked the insights that I got while implementing that, and the EVM framework introduced two things. It introduced the generics on the data, on transaction block config, and it revoked the handler in more trait-like way. So it's more easier to use. Few examples of that is basically how are basically of the optimism. That was the first first chain that was included in REVM in sense of it was included as the feature. It was very like intrusive. With the handlers, I succeeded to extract some functionality to the handlers, but with EVM framework, that become even easier. Currently, it stands its own crate. I still have work to do on EVM frameworking, but it become a possibility. Another chain is Scroll that did the similar thing on their own repo. Just imagine like every EVM chain doing their own creates and having Foundry, Red, or all the tooling support those variants of REVM. And all be tested, all be done in basically, it eases the integration with all the stack. The split that was inside that I had with the handler is there is split between the data that is currently context and the handler that is the logic part of REVM. Context contains transaction block, usual things. It contains journaling state that allows you to revert things when the revert happen in the calls. And it contains database that fetch the runtime data. Transient storage and warming of account is all done in journaling. Handler, on the other hand, has 4 parts. Validator that validates the interaction between block, transaction, and config. Config can have chain ID that needs to be checked with the transaction chain ID, for example. Pre-validation do some warming, deduct the caller balance, do EIP 7702. Change delegate code to the state. Execution is a little bit complex. It has 2 main loops. The frame is the loop around the calls, and interpreter is loop around the bytecode, basic instructions. And in the end, we have post-execution that does refund of not spent gas. It reimburses the caller. It basically rewards the beneficiary and creates the outcome of the execution. In code, as you see, context has a lot of generics, and it allows you basically to have it generalized. There is some to-dos to do. Spec needs to be moved inside configuration, but in general, this is the first view of the new context in EVM framework. Validation bar, one of the 4 stages in the handler, has basically self-contained. It contains associated types of the context, an error, a few functions that needs to be called. Other handler types are in similar fashion made, and you can have Ethereum validation that basically does the Ethereum specific implementation. Many EVM become just the context and the handler. And to create your own EVM, this is an example of main EVM. It's still pending, and it's probably going to be changed in small or maybe medium way. You basically specify everything you need. For example, you have your context with some predefined data. The section N, for example, are the structure inside REVM, but you can add your transaction implementation on it. And you have specified the handler that has their own functionality. Execution, Ethereum executor has few fields that are maybe they're interesting to people. They have a precompile provider and instruction provider, where you can generate your basic list of precompiles, and there is trade that you need to implement for this to happen. On the other hand, this is an example of inspector main EVM. It's still work in progress, but the idea is you create your own inspector types that implement those traits, and you can just override it. In the end, this inspector main uses the DB and inspector generics. And this is how you use it. There are probably going to be some helper function that is allow a little bit more flexibility and utility. But I wanted to show you just an example how this could look. It's, yeah. In the end, I assume a lot of users are going to come and implement their own EVM or their own like extensions and just use REVM in that form. I think that's it. Thank you very much for having me, and that's it.
Thank you, Dragan. It's really amazing what you have managed to do all those years with REVM. So let's start with our questions. The first question is about testing. So do you use any kind of equivalent testing or basically differential testing as part of your CI?
Yeah, on every PR, state tests are run, basically state tests made by Ethereum Foundation, the testing team, and it's like a good first line of defense if everything is okay, if everything works. Other than that, there is fuzzing team, fuzzing project that are run in the background by Ethereum Foundation by, I think, Martin Razit from Go EVM Lab, from Go Ethereum, but Go EVM Lab, I think, is project. But yeah, there are few stages of the testing done.
And this is based on every new PR, or?
Yeah, for fuzzing is done in the background.
Okay.
It's not on every PR, but the state test, running it on the WebAssembly, some specific Rust target, running it on different targets basically allows you to test all those things.
Mm-hmm. So are there any early architectural decisions that you have regret?
Yeah. I think I didn't understood how the calls and everything around that works. I still struggle with that. I didn't find a good fit on top of it. The frame and how the frame basically works with other frames, it seems it's nice, but I still need to land on the good abstraction on top of it. Initially, the calling, a sub-calling was behind the, basically, you call your subcall and stack became the problem. So I needed to move all that to the loop. So yeah, there are a few of those things.
The next question is if there are any plans to natively support ZK VMs like SP1, because currently you need to do some hacking patches to be able to run them.
We should talk with them, basically. EVM framework is idea that basically would allow and support this.
Great. Another question, again related to ZK VMs. So RVM is now used on both CPUs and the ZK VMs, and these two environments have very different performance profiles. How can you optimize for the one or the other or both?
In general, everything is Rust compiler, so it compiles optimization of DARM basically on Rust compilers. So the target is different. ZK VMs use RISC-V, while the CPUs has different instruction set that are maybe more performant. In general, I didn't do the testing on top of it, so that would be like a good way to check those.
I guess a follow-up here is, and probably you haven't checked yourself, and that's more about the ZK VMs, but have you any intuitions that some LLVM optimizations might be better for ZK VMs, or maybe better to not use some optimizations? Compiler optimizations, basically.
I'm not sure. I didn't look at it.
Great. So what is missing in REVM to be more performant than EVM1?
I have some tasks in my backlog. They require basically testing. Every change that happened on the performance side needs to be tested, measured, then validated that assumption that I made are correct. So I need to look at tail call optimization to check it. I need to look at the stack verification if this extracted from the instruction to before instruction to the main loop, if this is going to affect the performance.
Mm-hmm. Is it easy to add new precompiles?
Yeah, it was one of the use cases that Odyssey used a lot, and it was very easy. It's one of the biggest use cases of how you can extend, easiest and biggest ways to extend the REVM.
What's the most interesting use case that you have seen so far?
ZK VMs was really unexpected, to be honest. It just landed and it was like, hey, it can be used in that way. I didn't expect that. Yeah. I made it NoSTD to use it in maybe front ends so that JavaScript can be implemented on top of it. Maybe it can be used in Wasm as some project that does that way. But ZK VM was like unexpected surprise. And it was amazing in general.
Let's thank again our speaker, Dragan, for the excellent presentation.
Thank you.